The product rule. You use the product rule when y is equal to a function in x multiplied by a separate function in x. Alright? If y is a function in x times a function in x, well then dy dx is equal to u dv dx plus v du dx. Right? And that's the product rule. An example. If y was equal to x squared minus 3 times 2x plus 4. Now, of course, you could multiply these out and convert it into a polynomial. But to use the product rule, you let u equal to the first function, and you let v equal to the second function. From that, you can get du dx. Differentiate x squared, and the minus 3, 0. And from this, you can get dv dx. Differentiate the 2x, 2, and the 4. So then dy dx is equal to u dv dx plus v du dx. It is equal to u x squared minus 3 times dv dx plus v 2x plus 4 times du dx, 2x, which is 2x squared minus 6 plus 4x squared plus 8x. So it turns out to be 6x squared plus 8x minus 6. Of course, that's the slope of the tangent to that curve also. So, right? So that's your product rule. If y was equal to x squared minus 4 times 3x cubed minus x squared plus 9. Again, that's a function in x multiplied by a function in x. But again, it'll be a bigger job to multiply this out. So you let u equal to the first function, and you let v equal to the second function. From that, you can work out du dx. Differentiate x squared, 2x, and 4, 0. And from this, you can get dv dx is equal to 3 3s are 9x squared minus 2x, and the 9 becomes 0. And then dy dx is equal to u dv dx plus v du dx, which is equal to u x squared minus 4 times dv dx, 9x squared minus 2x, plus v, 3x cubed minus x squared plus 9 times 2x. Do that? Got it there now? So that's equal to x squared by 9x squared, 9x to the power of 4, and x squared by minus 2x cubed. Minus 4 9s are 36x squared, minus by minus plus 8x, plus 3x cubed by 2x, 2 3s are 6x to the power of 4, minus 2x cubed plus 18x squared, plus 18x, correct? 9x to the 4 and 6x to the 4 is 15x to the power of 4. Minus 2x cubed minus 2x cubed minus 4x cubed. Minus 36x to be squared plus 26x. Have you any questions? So there is your product rule. Right? Another product rule will be if y was equal to x squared minus 5 times the cosine of x. You now have two separate functions in x. The first function in x is what? X squared minus 5. And what's the second function in x? Cosine x. So u would be equal to x squared minus 5. And v will be equal to the cosine of x. du dx will be equal to differentiate x squared, 2x and the 5, 0. And dv dx will be equal to differentiate cos x minus sine x. Yes? I'll write that up there. See this rule here? Cos x becomes minus sine x. I just stuck that page there. Then dy dx is equal to u dv dx plus v du dx. It is equal to du x squared minus 5 by dv dx minus sine x plus v cosine x by 2x. That'll be minus x squared sine x plus 5 sine x plus 2x cosine of x. So we use the product rule when we have a function in x multiplied by another function in x. If it's not possible to multiply them out, or if it's too much work to multiply them out. That first one I did, or one of the first ones, if I said y is equal to x plus 2 by x minus 3, you could just say y is equal to x squared minus x minus 6, and then that dy dx is equal to 2x minus 1. That's easier than a product rule. But in a lot of them, you can't multiply them out. Could you multiply that by that? No, so you have to be able to use the product rule. The next rule is the quotient rule. And we use that when y is equal to a function in x divided by a separate function in x. Yes? And that's when we use the quotient rule. If y was equal to 2x minus 3 all over x squared minus 4, then u is equal to 2x minus 3 and v is equal to x squared minus 4. du dx is equal to 2 and dv dx is equal to 2x. And then dy dx, the quotient rule, is v du dx minus u times dv dx all over v to be squared, which is x squared minus 4 times minus u 2x minus 3 times dv dx 2x all over v to be squared, x squared minus 4 to be squared. 2x squared minus 8 minus 4x squared plus 6x all over x squared minus 4 to be squared. So as minus 2x squared plus 6x minus 8 all over x squared minus 4 to be squared. Now, we never multiply out the bottom, so we don't. What we try to do is factorize the top, yeah, and see if we could get an x squared minus 4 up there and be able to cancel it. You rarely can. You can't factorize the top there in order to get an x squared minus 4. It's not going to be in that as a factor. Do you understand what I'm saying to you there? So we would generally, you would leave the bottom as a square, and unless you can factorize the top and cancel, then you wouldn't multiply out. Now, y is equal to x all over x squared plus 1. Function in x, u is equal to x, v is equal to x squared plus 1. du dx is equal to 1, and dv dx is equal to 2x. And then dy dx is equal to v du dx minus u dv dx over v to be squared. V, x squared plus 1 times 1 minus u, x times 2x all over v, x squared plus 1 to b squared. That's x squared plus 1 minus 2x squared all over x squared plus 1 to b squared, which is minus x squared plus 1 all over x squared plus 1 to b squared. Have you any questions? Now, you would have got some questions last night that were quotient rules. Y equal to x cubed plus 1 over x plus 1. Yes? That could be a quotient, but it is easier to divide that because the top can be factorized. It's the sum of two cubes. So say it's x plus 1 times x squared minus x plus 1 all over x plus 1. They cancel. So say that's just giving you y equal to x squared minus x plus 1. Therefore, dy dx is equal to 2x minus 1. Or last night, they would have given you y equal to 2x plus x squared root x all over root x. Now that could be done as a quotient rule. But what about it? Well, it's easier to divide it. It's just easier to say y is equal to 2x over root x plus x squared root x over root x. Root x will go into x, so that's twice root x. And then root x cancel, giving you x squared. So therefore you can say dy dx is equal to twice 1 over 2 root x plus 2x, which is 1 over root x plus 2x. In other words, in both these cases, there were quotient rules, but what was it easier to do? It was easier to divide, to simplify. Whereas in this case, couldn't simplify. So what you have to use? The quotient rule. Could this have been done by a quotient rule? Could. But what? To get 2x minus 1, there would have been a factorization involved in it, cancelling between the top and the bottom to end up at 2x minus 1. Are they the right factors there? X by x squared, just a multiply x cubed. X squared by minus x squared. And x squared by plus 1, plus x. And once x squared, plus x squared. And once minus x, and once 1, 1. What will that give me? Just to be sure that you were right, it may be a little while since you factorized the sum of 2. Have you any questions? No?